Swayam Prabha. Digital India. Educated India.
Welcome to the 8th lecture in mechanics of materials. The last lecture we saw about transformation of stresses. Basically we saw Mohr circle equations which will correspond to a state of stress which is plane. A plane state of stress can be represented using a square like this. Okay. So, what we were interested is to represent how the components of stress changes when the coordinate system is rotated from say Ex to Ex star or Ey to Ey star and so on. We saw that the given stress state in xy can be represented through a circle, can represent the state of stress that will come about from that stress state as a coordinates of a circle. Okay. So, basically you draw on the x axis the sigma xx and on the y axis you draw the shear stress. Basically you fix the point sigma xx and sigma xy as this point, and sigma yy would be minus sigma xx. You fix these 2 points, join them by a straight line. The center would be sigma xx plus sigma yy by 2, and then now you got the requirements to draw a circle. You got the center of the circle and you got the radius of the circle. So, you can now complete the circle here. If you complete the circle, the extremum normal stresses where the shear stresses are 0 are the principal stresses are sigma max and sigma min. Similarly, the extremum shear stress would be tau max, which is basically your stress at the center of the circle, the shear stress at the center of the circle. Okay, that will be equal to the radius of the circle. Okay. Now, if I rotate Ex to Ex star in anticlockwise sense by an angle theta, I have to rotate that by 2 theta in the Mohr circle in the clockwise direction, and hence this rotated plane will give you the coordinates of sigma x star, sigma x star y star and sigma y star and minus sigma x star y star. Okay. So, this is what we saw in the last class in brief. Today we will draw some Mohr circle for certain special stress states, as well as we will see definition of a few stress states. Okay. Now, I am interested in a stress state wherein say I have a uniaxially stressed body. Let us say I have a uniaxially stressed body. I am applying a force P. Let me assume that this force is uniformly distributed over the side. Hence, the stress state, if I take this as Ex, Ey, the stress state of the cube would be uniaxial stress sigma xx acting like that, and the other components are 0. Okay. So, how will I draw the Mohr circle for this? The Mohr circle would be, this will be sigma n, the normal stress components, this will be the shear stress components acting on the same plane. Okay. So, what I know is, I know that there is no shear stress in this state and there is no stress in yy. So, this is a point on the circle and the other point on the circle is this is sigma xx. Okay. The stress that is produced by the uniaxial state of stress. Okay. Now, the Mohr circle would be a circle of that nature. Okay. Now, you will find that the maximum shear stress in this case would be this line, wherein this point is sigma xx by 2 and this radius is also sigma xx by 2. This will be sigma xx by 2 is the maximum shear stress for this state of stress. Okay, this will be sigma xx by 2. So, now in what plane does it occur? The maximum shear stress, this angle is 90 degrees. So, I have to rotate this system by 45 degrees for me to get the maximum shear stress location. This will be Ex star, Ey star on which the maximum shear stress occurs. Okay. So, if I were interested in finding this E x star, which is what will it be? E x star would be cos 45 E x plus sin 45 E y, right. So, that is a normal on which the maximum shear stress occurs. Okay. Now, let us not go by your Mohs circle or transformation rules, but just let us do it by area transformation and components of forces, how you get the same expression for the stress at 45 degree plane. That is, if I cut this at 45 degrees, what is the stress on that plane is the question that we are going to answer now. So, basically you have this 45 degree plane whose normal is n, which makes an angle 45 with the horizontal. Okay. So, basically you have force P acting like this, the component of these forces along the normal direction and parallel to the surface would be P by root 2, because this is 45 degrees. Okay. And then what happens, this P by root 2 is distributed over this inclined face, this P by root 2 is distributed over this inclined face, and hence the stress would be sigma n would be P by root 2 by B, which is the width of this, block, this is B, and if this is the depth is h, it will be it is going to be root 2 times h, because this side is h, this is 45 degrees. So, this distance would be root 2 times h. Okay. So, that will be root 2 times h. So, this will be P by 2 times B h, that will be sigma x x by 2. Okay. Similar argument goes for the shear stress on a plane. Shear stress on a plane is P by root 2, the force is distributed over the area B times root 2 of h, distributed over the area B times root 2 of h. So, this is again going to be P by 2 times B h, which is sigma x x by 2. Okay. So, if I were to draw the stress cube at that 45 degree inclination, I will have sigma x x by 2, I will have a shear stress acting like this, sigma x x by 2, and each of these shear stresses are sigma x x by 2. Okay. So, that is how the state of stress will act on that inclined element. Okay. Now, if I were to represent this as a stress tensor at this 45 degree line, I will have sigma represented as sigma by 2, sigma by 2, sigma by 2, sigma by 2, 0, 0. This is the representation of the stress tensor. So, what you have to understand is this is same as writing it as sigma 0, 0, 0, 0, 0, because all this represent the same stress tensor. In other words, any point on this Mohs circle represents the same state of stress, which is the uniaxial state of stress. This stress is called uniaxial, this is called as uniaxial state of stress. Both the representations that I have shown here represent the same stress state. In fact, there are multiple representations of the same stress state. Those multiple representations are any point that is on the Mohs circle will represent the same uniaxial state of stress. Okay. So, what you have seen now is we have seen one of the stress states, which is called as the uniaxial state of stress.